15 slow descent. At first, let's speak about pluses and minuses of the report. At first, let's start with a strong point of the report. So, at first, we can see interpretation of the problem. It's very good because if we know what we should do, it's more clear to understand. Then, also, we see consideration of falling of usual paper. It's a good point too, because if we know, because we don't know, maybe the usual paper can flow the bigger times than some other devices. And when we consider the falling of usual paper, we can see some types of falling which can help us to decrease time of slow falling. Also, we see that the reporter showed to us different types of devices. Yes, but reporter didn't check someone. Reporter checked someone devices, but also he tried to make some another, and it's really good. Also, we can see in the report a law of energy consideration. So if we know how we can decrease energy of kinetic energy, and so we know how to decrease time of slowing, and it's a very good point. And also we can see in the report a lot of experimental dependence, and it's really good. But also we have some minuses. At first, we haven't so clear explanation for the Magnus effect, so we don't know why we should, which length of the edge part should be for the bigger time of falling, and it's not clear. Also, we can see theoretical explanation for the variable parameters. We can see only experimental points. So, and it's not really good because we can't say why it happens. And it's another point that we can see only experimental plots. And finally, I think it's the main wrong point, because that we can see final dependence on all parameters. Because if we, for example, increase the surface of our device, so we have constant mass of the list, and if we increase one parameters, we should decrease some another parameters. That's why it's should be some final dependence which show to us in which parameters we have the biggest time of falling. And now let's go to the discussion. At first, let's start with pluses. At first, opponent asked about reliance of device. It's a really good point because in the presentation we can see how it's released, and we don't know about some accuracy of the experiment. Also, opponent asked about lift force. I think it's a very good point because if we have the drag force, it means that we have a lift force too, because it's some this force exists only together. Also, we opponent asked about condition of experiment, and it's a really good point, and case of usual paper. So let's go to the minuses. At first, really know its number. We can see some estimation in the reporter, but the reporter didn't use it in presentation. Also, temperature failure. I didn't think that it's an important parameter. And finally, another decision. Okay. Thank you for your attention.
Thank you, reviewer and opponents, for your good remarks. So here is my summary of my presentation. So in summary, we have determined flight time that flight time is determined by maximizing gravitational potential energy conversion into vertical kinetic energy, and we can maximize flight time by converting more potential energy into other forms of energy. And the best device will be the tumble wing because it makes use of the most modes of dissipation, such as forward velocity, rotation, and dissipation through the modes of drag, lift, vortex shedding, and flexing. So yeah, this is why it's better. And the flight time of the tumbleweed can be optimized by maximizing surface area. It needs to have an aspect ratio of 4.5, it needs to have a narrow edge width as possible, and a moderate launch angle. So, to address the issues of the opponent, we did observe dissipation of energy in air through our vortex shedding experiment. And we do not know, we cannot quantify how much energy is dissipated theoretically, but we know that larger shedding frequency and a larger vortices will lead to more energy dissipated. So here is a picture of how the experiment is done. We use an aluminum plate, and this will be the vortices. So this will be the regions, the vortices will be the regions of lower pressure, and there will be a high pressure in front, and this creates an upward force. And as for the reviewer, she pointed out I did not address the Magnus effect. So this is what the Magnus effect is. So as a device, let's take a cylinder for example. As it is rotating in an oncoming flow, this part will have a larger boundary layer than the top part. And based on the Bernoulli's equation, this would create a region of lower pressure, and this would be a region of higher pressure, and this would generate lift as we discussed in our presentation. And here is how density can be derived from changes in temperature, and however, we do not think that is a significant factor because it will lead to a systematic shift in relative flight times and will not affect our results.